Question 26, 2x plus 3y equals 7, 10x plus 15y equals 35. For each real number r, which of the following points lies in the graph of each equation in the xy plane for the given system? Okay, so what we can do is we can solve this first. So what I want to do is multiply the first equation. Let's use elimination. The first equation, sometimes they write it like that. I'm going to multiply by 5, so this will turn to 10x, but let's use -5 so we can get the opposite sign. And sometimes they write it like that, or you could do it a little neater, would be like that. This times -5, and this times -5. Careful, don't put -5 or subtract 5. 7 subtract 5 is 2, but we're gonna multiply by -5. Okay, -5 times all that, -5 times all that. -5 times 2x, you get -10x. -5 times 3y is -15y. And 7 times -5 is -35. That's the first equation. Let's write the second one down. 10x plus 15y equals 35. This plus this is 0. This goes to 0. And this goes to 0. You have 0 equals 0. This is a situation of an infinite number of solutions. What we have is a case of coincident lines. These two lines are simply overlapping. You know, it's one line on top of the other. They are the same line, identical line, coincident lines. Okay. So every point on the line is a solution. It's got an infinite number of solutions, but the solutions are on the line, not just some random point. It's any point on the line. Okay. So now we need to write down these lines. Let's do them y in terms of x and x in terms of y. I'll work with the first line. The second line is the same line. If you divide this by 5, you get the first line anyway. So let's write this down. 2x plus 3y equals 7. 2x plus 3y equals 7. I'll do it once here. I'll solve for y. And later on, I'll solve for x. So to solve for y, you subtract 2x. Subtract 2x. You'd get 3y equals -2x plus 7. This is -2x plus 7. There's a positive 7 and a -2x. And you divide by 3, and divide by 3, and divide by 3, and you would get y equals -2/3 x plus 7/3. Let's hold on to that real quick. Now, let's do it again. 2x plus 3y equals 7. This time we will solve for x. Okay, so we subtract 3y. You're trying to isolate the x. Subtract 3y. You get 2x equals -3y plus 7. And you divide by 2, divide by 2, divide everything by 2. X equals -3/2 y plus 7/2. This is x in terms of y. Okay, so now they're saying for each real number r, which of the following points lies on the graph of each equation? Okay, so basically they're saying if y stood for r, then over here, if y stood for r, x in terms of r would look like that. And if x stood for r, and it'll be clear when we look at the options. So this one says r over 5 plus 7, negative r over 5 plus 35. Let's come back to that. Here it says, okay, if your y coordinate were something, then this would be the x coordinate in terms of that. And let's look at that. X equals -3/2 y plus 7/2. Ooh, that looks good. That's actually the answer. That matches exactly. It's saying for any given y value that you have, if this were some number, let's say this were r, then you would have -3/2 r plus 7/2, and that's exactly what they wrote over here. This is the same as -3/2 r. Okay. Let's look at this one. If x were some number, what's y in terms of that? This is very close. We would like -2/3. If this had a negative sign, then this would be the answer, actually. C would be correct. But the way it's written, because it's +2/3 r, and we have a -2/3, It's very close, but it's not correct. The 7/3 matches correctly. Everything matches except this doesn't have a negative sign there, so this is wrong. And this is 3/2, negative 3/2. They had this backwards. If they switch to 2 and 3 and you have 2 on top, 3 on the bottom, then D would be correct. So that's why D doesn't work. So the answer is B, because it fits exactly what we have written over here.